This is SpaceTime Series 26, Episode 87. Coming up on SpaceTime, the man on the moon gets his clock reset by 200 million years, new clues about when plate tectonics began on planet Earth, and the final flight of Europe's workhorse rocket, the Ariane 5. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have reset the clock for craters on the moon, meaning that parts of its surface, those which characterise the children's story The Man on the Moon, are actually around 200 million years older than previously thought. The findings, reported in the Planetary Science Journal, are based on a coordinating and recalibration of two conflicting systems of dating the surface of the moon. The new evaluation shows that large parts of the lunar crust are actually around 200 million years older than had been previously thought, allowing scientists to better clarify the sequence of events in the evolution of the moon's surface. These days, our moon is pretty geologically inactive. That means that the craters from asteroids and comets which bombarded the moon throughout its history to give it its appearance haven't been eroded away by time. Of course, the Earth itself received a similar barrage throughout time, but constant erosion and plate tectonics have erased most of these impact features. Now, the standard way of measuring the surface of any celestial body, such as the moon, is a process called crater counting. Put simply, the more craters, the older the surface. But this actually gives a very different result to that seen when examining rocks from the Apollo missions, especially for the light areas of the moon such as the highlands. One of the study's authors, Professor Stephanie Werner from the University of Oslo, has told the Goldschmidt Geochemistry Conference in Lyon that her team decided to reconcile these differences by correlating individually dated Apollo samples to the number of craters in the sampled site's surrounding area, in effect resetting the crater clock. They also correlated them against spectroscopy data from various moon missions, especially the Indian Chandrayaan-1 mission, to be sure which Apollo samples belongs to the surface in which they counted craters. This time-consuming task took almost a decade. But the authors found that by doing this, they could resolve the discrepancy and push back the age of the surface of the moon by up to 200 million years. For example, the age of the Imbrium Basin, filled with the lunar sea, the Mare Imbrium, which is visible in the top left of the moon, and which was probably created by the impact of a giant asteroid about the size of Sicily, goes back from 3.9 billion years to around 4.1 billion years ago. Of course, none of this changes the estimated age of the moon itself. It was formed 4.5 billion years ago when a Mars-sized planet, which we now call Theia, slammed into the early proto-Earth. But what the new system of dating does is change the ages of all areas on the moon's surface, not uniformly, but with the oldest surfaces showing the greatest changes. Werner says it's an important difference because it pushes back the date of the late heavy bombardment epoch. Now, the late heavy bombardment is a period in our solar system's history which saw a massive increase in asteroid and comet impacts on bodies in the inner solar system. It was most likely caused by the outward planetary migration of the gas giants Jupiter and Saturn to their current orbital positions. As they migrated out, the gravitational perturbations flung material around them towards the inner solar system. What it means is the late heavy bombardment took place before the more extensive volcanic activity which formed the man-in-the-moon patterns, the Mare volcanic plains, including Mare Imbrium. As this happened on the moon, the Earth was almost certain to have also suffered a similar early bombardment. But because most of the Earth's evidence is now wiped, the moon provides unique records of this early bombardment history. So far, we've had 3 successful lunar sample return programs. These were the American Apollo missions, the Russian Lunar missions, and China's Chang'e mission. By combining the latest spacecraft observations with impact events recorded by lunar rocks, Werner and colleagues have greatly pushed back the records for the late heavy bombardment. And that's important because this heavy bombardment period must have affected the origin and early evolution of life on Earth, and potentially on other planets such as Mars as well. And of course, bringing back rock samples from Jezero crater on Mars will be the next giant leap forward in the search for signs of ancient life on other planets in the solar system, and also exactly when it happened, if indeed it did. This is SpaceTime. Still to come, new clues about when plate tectonics began on Earth, and we look at the final flight of Europe's workhorse, the Ariane 5. All that and more still to come on SpaceTime. A new study claims Earth began plate tectonic activity and subduction around 3.8 billion years ago. The findings, reported in the journal Science Advances, challenges all previous studies which suggest that plate tectonics began within 200 million years of the planet's creation, following the Theia impact which created the Moon 4.5 billion years ago. Earth is currently the only planet known to harbour life, and that is thanks in a large part to the operation of plate tectonics, which recycles critical biochemical elements and maintains a planetary thermostat. Subduction, the destructive force of plate tectonics that pushes one plate beneath another, is the most telltale sign of tectonic's great recycling program. But how far back in time can we really trace evidence for plate tectonics? Did Earth's plates always function as they do today, with subduction and surface material recycling? Previous studies using numerical geodynamic modelling argues that subduction and recycling were operating from as early as around 4.3 billion years ago. Now, since the Earth itself is only 4.5 billion years old, such a claim generally argues that plate tectonics were happening almost from the very beginning. However, new geochemical evidence from some of the world's oldest rocks, found in the remote lake regions of northern Canada, paints a starkly different picture of Earth's earliest history. The new study shows no signs of surface material recycling at 4 billion years, and the earliest evidence of surface recycling in the magmas dates back to just 3.8 billion years. The key to all this is silicon and oxygen isotopes in granite rocks. They act as tracers for surface material recycling into magmas. On ancient Earth, seawater was saturated with silicon due to the lack of life forms to consume it. Therefore, any heavy silicon materials from the seafloor were recycled back into magma chambers by subduction. Then, heavy silicon isotopes could be detected in granitic rock samples. One of the difficulties in applying this technique to ancient rocks is identifying primary silicon isotope composition. That's because these rocks have been reworked by heat and pressure repeatedly through Earth's history. And that's where zircons come in. They're the most abundant datable material in granitic rocks, and conveniently, they're also resistant to weathering and later alteration. So they're really like tiny little chemical time capsules. Applying ultra-high precision analytical techniques to zircon can provide the most reliable constraints on whether the detectable silicon isotope composition represents the primary signature. The study proposed systematic screening criteria for evaluating the data, carefully evaluating zircon, silicon and oxygen isotope signatures. And the authors found an abundance of heavy silicon signatures in the 4 billion-year-old rocks, which implies that the oldest samples didn't undergo subduction, in other words, no plate tectonics. However, given that these oldest rocks are just from a single location, the lack of subduction in that area doesn't mean plate tectonics wasn't going on elsewhere on the planet. Now, after careful filtering through, the data also revealed a distinct shift at 3.8 billion years in both silicon and oxygen isotopes. And it's for this reason, based on the current data, the studies concluded a possible change in the Earth's geodynamics, such as the onset of plate tectonics and subduction, probably occurred around 3.8 billion years ago. This is SpaceTime. Still to come, we say farewell to the Ariane 5 as it undertakes its final mission. And later in the science report, a new study blames the fishing industry for most of the plastic pollution in our oceans. All that and more still to come on SpaceTime. It's the end of an era, with the last ever launch of an Ariane 5 rocket successfully placing 2 new telecommunications satellites into space. Ariane Space Flight VA261 lifted off from the European Space Agency's Kourou spaceport in French Guiana, carrying the 3,408-kilogram German Aerospace Agency DLR's Heinrich Hertz experimental satellite and the 3,572-kilogram French Syracuse 4B satellite into their respective geostationary orbits.
À tout de DDO, Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité. Top, allumage moteur Vulcain. Allumage 2EAP, décollage. Propulsion nominale. Tous les paramètres à bord sont normaux. Propulsion nominale.
Syracuse 4B and Heinrich Hertz satellite blazing a trail on board the last ever Ariane 5 across the equatorial skies, and we can hear the rumble of her engines as she flies over.
It's very impressive, and we are, 11 kilometers from the pad, and the delay of the vibration is a bit amazing. We cannot get tired of it.
Nominal.
He's telling us that the trajectory is nominal. Everything is going according to plan. 1 minute and 56 seconds into the launch of Ariane 5.
Nominal.
So the propulsion is working perfectly, nominally, as we say in the space jargon. The booster separation.
Séparation de 2EAP.
Wow.
And we have confirmation from the range operations manager.
Look at this. That's absolutely amazing.
Those two boosters on the right and the left being jettisoned. The Vulcan engine.
So they are providing 90% of the overall thrust. And so they have been jettisoned. They are 240 tons each. The launcher on the ground was 771 tons.
And we don't need them anymore. We're shedding weight.
So everybody is completely nominal. So next step is the separation of the fairing.
That's coming up in about 10 seconds. And separation there of the fairing is what it looks like.
Séparation de la coiffe.
We have confirmation there of separation of the fairing.
The flight was the 117th and final mission for Europe's Ariane 5 workhorse, which first flew way back in 1996. During an illustrious 27-year career, the 52-metre-tall two-stage rocket carried some of the most advanced scientific instruments, including ESA's comet-hunting Rosetta mission, the joint ESA-NASA James Webb Space Telescope, and ESA's JUICE mission to Jupiter. And of course, there are also multiple ATV cargo ships carrying fresh food and supplies to the International Space Station. Unlike its predecessors, the Arianes 1, 2, 3 and 4, which were all really a series of evolutions on the same basic design, the Ariane 5 was an all-new launch system, specially designed to carry far heavier payloads, 20 tons into low Earth orbit and almost 11 tons into geostationary orbit. Its replacement, the Ariane 6, is well behind schedule. Originally slated to begin flying in 2020, the new launch is now only reaching its final pre-launch preparations. In fact, only last month, Arianespace retracted the mobile gantry, thereby revealing the first Ariane 6 launch vehicle on its launch pad ahead of its first hot-firing test of the core stage Vulcan 2.1 engine. The inaugural flight of the Ariane 6 should take place before the end of this year. No final date has been given. The Ariane 6 builds heavily on the heritage of its Ariane 5 predecessor, but it will carry more payload for lower cost, it'll fly more often, and it'll be far more flexible. The Ariane 5 used 2 strap-on solid rocket boosters to aid its launch, but the Ariane 6 can carry either 2 or 4 of these boosters, thereby varying its payload capacity. As the production line for the Ariane 5 began to slow down to a finish, Arianespace were planning to rely more on Russian Soyuz rockets to fill the gap until Ariane 6 begins. But the boycott of Russia following Moscow's invasion of Ukraine in February last year put an end to that program. And of course, another setback hit in December when Arianespace's next-generation Vega C light launch vehicle failed during launch, grounding future flights. The Vega C is based on one of the strap-on boosters used by the Ariane 6. This is SpaceTime. And time now for another brief look at some of the other stories making news in science this week with a science report. A new study has found that the world's oceans have changed colour to become greener over the past 20 years. The findings, reported in the journal Nature, may be a marker of climate change affecting the planet's phytoplankton, the photosynthesizing microbes which form the basis of the ocean's food web. The researchers say any changes to the colour of the ocean would affect how light passes through the seawater, which could itself have a significant effect on life within the oceans. Now, keeping with our nautical theme, a new study has found that the fishing industry is responsible for most of the plastic pollution found in our reefs. The findings, reported in the journal Nature, show that over 90% of reefs have plastic pollution and debris in them. Scientists found macroplastics, things larger than 5 centimetres, accounted for 88% of the plastics found, and these levels were highest in deep reefs between 20 and 150 metres down. They found fishing lines and nets and discarded traps make up most of that pollution. And it doesn't end there. Researchers also looked at some lakes. They found microplastics in all 38 lakes and reservoirs in the 23 countries they tested. That was part of an exercise which looked at the amounts of plastics and microplastics polluting the world's lakes for the first time. The findings, reported in the journal Nature, show that plastic fragments and even fibres from washing clothes and packaging residues in freshwater lakes and reservoirs are higher than those in the plastic gyres of the ocean, the so-called plastic garbage patches. What it all means is that plastics are the largest and most harmful and persistent fraction of marine litter, accounting for at least 85% of total marine waste. An estimated 14 million metric tonnes of plastics enters the world's oceans every year, with estimates of over 170 trillion plastic particles currently afloat in the world's oceans, wreaking havoc on livelihoods and ecosystems and destroying wildlife on a massive scale. Worse still, estimates suggest that number is expected to triple over the next 20 years. People are now dying from a new fad doing the rounds of the hippie communities across the New South Wales Northern Rivers hinterlands behind Byron Bay. They're poisoning themselves by consuming secretions harvested from the back of an Amazonian tree frog. Tim Mendham from Australian Skeptics says the poisons can cause psychedelic experiences, but it can also kill.
Yeah, this is a bit of a cultish treatment experience, if you like, that especially among sort of new agey type, old hippie type personalities, if you like. Often they have ceremonies which all sorts of different things are going on. They might be taking some psychedelic drugs and that sort of thing to improve their spiritual well-being. But also this thing that's cropped up fairly recently, it's an old thing in South America, in the Amazon rainforest, of scraping a bit of sweat or even poison off the back of a particularly virulent frog. It's the Amazonian tree frog, and using that liquid to put on your skin. Now, first of all, you have to take a little stick and you sort of pierce holes in your skin in a sort of a nice little dot pattern, and then you insert this poison into those holes. The trouble is it can have a really dangerous effect. Even, in fact, it's been known to kill people. As part of a mind-expanding, spiritual-enhancing event or technique, some people find it very, very interesting, but it can cause all sorts of conditions ranging from choking to extreme diarrhea, headache, dizziness, all the usual things. And in some cases, if someone has severe choking, they can actually be coughing up. And in one particular case recently, someone broke their esophagus and they died accordingly. Obviously, their throat swelled up, they couldn't breathe, turned blue, and by the time an ambulance got there, it was too late. The trouble is, all the other people are there sort of having their little cultish activities in this particular case, especially.
What's going on, I take it.
So that's right, yeah, they were doing their shaman practice and that sort of thing, and they figured, oh no, he's just going through a process of cleaning up antitoxic.
Man.
Yeah, that's right. And that's the trouble, it went too far and he died. And the weird thing was that one of the people there told the ambulance people to get out of the way because they were interfering with the man's aura, which I presume not many ambulance people have heard before when they're trying to help someone save their lives, that they're interfering with their aura. But obviously that might be a bit extreme. Other people were more concerned and sort of did try and look after him, but too late. And it's not the first. There's been several deaths from these frog poisons. These things have been going on for a while, and the ones that recently in the news that are currently going through an inquest to find out. There's a second one not that long ago as well, where a woman who had been trained in how to apply this Cambo frog poison died herself from it in much the same way. It's pretty gruesome the way people die from this. They're choking, they're, sort of have extreme diarrhea, all sorts of horrible things are happening to themselves. Not the most pleasant way to go.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.